it's just occurred to me we really haven't had a completely successful test of this equipment.
I blame myself.
What's up, everybody? My name is Matt Lucier, and welcome to the first ever Test Tuesday, where today we're going to demo Cisco Modeling Labs. Why Test Tuesday? I want to use Test Tuesday as a way to demonstrate different technologies and how you can integrate them into your existing workflows. There's a lot of really cool technologies out there that you can do some really cool integrations with, and each one of these sessions I'm really hoping kind of builds upon previous videos. Why Cisco Modeling Labs? I'll tell you, if I had to access the Cisco Modeling Labs when I got started, it would have been a game changer. It's a super powerful tool that lets us learn new network configurations, test our existing production networks, and do so in a safe space without impacting our running environment. So what have I done with Cisco Modeling Labs? I've got VXLAN fabrics that I've run. I've done some automation against those fabrics. I've set up segment routing, and I've done some SD-WAN controllers just to experiment with the different technologies. So today I want to show you the CML UI and how to navigate Cisco Modeling Labs. I'm going to walk you through setting up a new lab, building out the nodes, showing you what's available in the system, and then we're going to actually start a lab and look at some of the available options and configurations we can do to get the lab running. So we'll go ahead and get started, and we'll log into the CML server. This is the Cisco Modeling Labs server, so we can see that it's prompting us for a username and password. If we look underneath the login button, we can see the current version that is installed in the box. I'm running 2.5.1. The latest release is 2.6.1. There are definitely a couple enhancements in the new product, so if you're going to install CML, I would highly recommend going with 2.6.1. If you check out the CML sandbox, which we'll talk about later, that version is also running 2.6.1 as well. So I'm going to go ahead and I'm going to log in. I've got a user called CML user1. And I'm going to go ahead and type in my password. And it's going to come up and it's going to bring us to this dashboard. So you can see that I have nothing running right now, but if we look at the UI, we can see that we have this dashboard, we have a tools button, which we'll look at in a few minutes, and we have these add and import buttons. If we wanted to create a new lab, we just click add. If we had an existing lab that we've created and we've saved previously, we could import that lab, or if we're moving something in that somebody gave us to trial or test out, we could do import. Once those labs are either added or imported, in the future you would see a list of labs on this screen here. We could select the lab and go ahead and start it up. You can also fire up multiple labs at one time using this checkbox here. One of the really cool things that I like to point out is there's some safety mechanisms in here to kind of keep labs from automatically getting deleted. So if someone were to come in here and stop your lab and go to try to delete it, it won't delete until you actually wipe the lab out. We'll take a look at that once we want a lab running. But it's a nice safety feature that if your lab is running and you've got some things in there that you don't want to lose, somebody can't accidentally delete it, because they'd have to wipe the lab out before they hit the delete button. So we'll see that in action a little bit. But let's go ahead and take a look at the tools available. So let's go up here and take a look at the tools. We can see that we have user tools and admin tools. Your admin tools are going to be things to manage the whole of the system. So if you want to go to a system administration and set a global user authentication scheme up, so instead of using local user accounts, we could do LDAP, or we could point to an Active Directory server. If you needed to do an upgrade, so if I decide to upgrade this to 2.6.1, I could use the upgrade system tool. Licensing, if you want to get your box licensed, get it connected to your Cisco Smart account, you'd use the licensing tool listed below. The ones on top, so node and image definitions, I'm just going to click on that, and you can see that these are all the nodes that we have configured. There are a couple of nodes on this box that I had added after the fact. So you can see here we've got vEdge, vManage, vSmart, and vBond. Those are not default images, but they're QCOWs that exist out on Cisco software. You can go ahead and install those, if you've got access to that set of QCOW files. But basically anything that runs on Linux KVM will run within the Cisco Modeling Labs environment. So sky's kind of the limit. I had a customer reach out and ask about doing Dell images, and we tested that out and got it working. You kind of got to work through each one because, it's a Cisco tool, so all the, stuff that's in there works really great with Cisco stuff. If you want to add something else, you might need to experiment with it to see how it works for your specific use case. So these are the nodes. These are the node definitions. So these are the actual like images themselves that are configured and what versions I have running out there. If we go back to tools, we can set resource limits. We can look at sample labs. So these are just a few sample labs that are available for you to import if you want to take a look at things. If we go to tools, and we can look at the client library, which is the Viral 2 client. So it's a Python package that you can use to interact with the server. Go back to the dashboard, go to tools again. We've got the breakout tool, which is a nice tool that you can run on your local machine, and you can actually use PuTTY or iTerm and actually interact with the Viral CML2 controller and interact with your box. So instead of having to come into the CML UI all the time, you could actually do everything from this terminal window. If we go back, couple more things. So there's API documentation. If you've got an interest in working with APIs and kind of learning how they work, there's an open API tool here that you can take a look at, and this kind of gets into all the things you need to do to authenticate. If you want to create users, work with your labs. I have a demo that I did for some customers that showcased how to use our CML API and build out a configuration from scratch. So like authenticate, actually push a lab to the device, see what labs are running, start and stop the lab, and then understand the state of the lab. So if you wanted to get to a point where you were doing automated deployments, you could use some checks with the API to see where the CML lab is before you proceed with other functions. And then the last thing is CML documentation. So this is just documentation around Cisco Modeling Labs, how to use it. This should be out on the Cisco site. We're looking at 2.5 here, but if you need to know about the VM images themselves, what the default username and password are, I don't know that it's in here, but there are instructions here to tell you how to log into each one of these things, and here it is right here. What is the default login? So if you have any questions about how Cisco Modeling Labs works, the documentation tab is a great page to look at, to see what the configuration is. So let's go ahead and add a new lab. So we're going to come here and we're going to click add. And it's going to bring us to this workbench where at the top we can see there's a predefined title set up. I'm going to go ahead and click this. I'm going to change the title to Test Tuesday Lab. I'm going to hit enter, or alternatively you can hit the check box at the end to save the configuration. So we see the lab has been named Test Tuesday Lab. If we come back to the dashboard, we can see now that the title is also set there. There's a preview icon that would show you a little bit of the topology, but since we haven't done anything yet, there's nothing to see. So I'm going to go back in, and the next thing we're going to do is we're going to add some nodes. So you see on the right that there's a option to drag a node to add it to the lab, and we have a variety of different nodes. I want to add a Catalyst 8000V and two Nexus 9KVs. If I click on the Cat 8000V, you can see that once you're highlighted over it, you can see how much memory is required and how many virtual CPUs. This is super important. So the system isn't so much CPU bound as much as it is memory bound. So whenever you assign a node to the box, it reserves some of that memory. So if you say, I want this 4 gig Cat 8000V, and then we come down here and we're going to look at the Nexus 9000. And since I said I want 2 of them, you can see that when it comes up, it says it requires 8 gig of RAM and 2 virtual CPUs. So if I were to count that in terms of memory, I'm using 20 gigs of resources, virtually. Why is that important? So when I spin this up, it's going to reserve that memory, and it's going to reserve 20 gigs of memory. It may not, the host itself may not actually use that memory. So if I have 64 gig assigned to the virtual machine, or I have a 64 gigs in a host, the server itself might not use that RAM. CML, however, is going to dedicate those resources when the node spins up. So really, we're memory bound with the application versus CPU bound. You definitely want to have those CPU resources to spin up the lab, but once the system kind of comes online and stabilizes, the CPU utilization, at least in my experience, has been less of a factor than memory. If I run out of memory and I exhaust memory as far as CML is concerned, I'm not going to be able to spin up more images, and they're going to hang until I either shut some images down or I add more resources to the virtual machine. So with that said, be cognizant of the images you're running. Some of these things are really big. In iOS XRV, for instance, if we highlight over that, it's going to say 20 gig of memory and 4 vCPUs is recommended. If you do anything less than that, the machine is going to struggle to run. So definitely do the recommendations. And like I said, just be cognizant of how many nodes you're running and how much memory those nodes need. So now I want to go ahead, I'm going to rename these images so I have a better understanding of what my devices are. These names that get defined initially are default names. Every time you add a new one, so if I added another Cat 8000V, it would be 8000V-1, which as I build out larger topologies is not going to be a clear definition of what that host is. If these things were emulating a physical environment, I might want to name them after my real world devices so that I know what configurations I've applied where, or where I want to apply them. So if I click on the 8000V here, we're going to name this guy Cat 8KV-RTR. And then I'm going to go to the Nexus 9000 and I'm going to call it N9KV-SW1. I'm going to copy that and I'm going to come over here, click on this host, and call this one Switch 2. So I have my nodes named the way I want them to be named, and I want to go ahead and get interfaces configured between each of the switches and routers. So I come up here to Cat 8KV router and I right click and say add link, and I go to the Nexus 9KV switch 1 and click on it, and I'm presented with this window. So we can see that Cat 8KV is going to use gig E1 and Nexus 9KV switch 1 has defaulted to management 0. This is not the interface we want to work because we want to use a data side interface. So if we click here, we see that ETH11 is an option. By default, we're always going to pick the first available interface. So if I create the link here, and let's say I want to connect the two switches together, I right click and add link. By default, they want to use their management 0 interfaces. So even if you select ETH11 on Nexus 9KV switch 1, it's not going to default to ETH2 as the next interface. It's going to go back to management 0. To get around this, one of the things I like to do when I set up my environment is use this unmanaged switch feature. I use this and I connect a link to my Nexus switches to the management switch. And that gives me a point that I could connect a Ubuntu host or an external connector to manage these switches within CML. We'll talk about that a little bit down the road, but I just kind of wanted to point out, like, this is a good way to avoid having to deal with the management 0 interface with Nexus switches or anything else that might have management switches or management port as its default interface. So now that that's set up, I can come back here to switch 2, add link to Cat 8KV router, and you can see now that Nexus 9K is using ETH11. Cat 8KV has moved up to its next port of ETH2. I actually want to cancel out of this and show you one other quick thing. If we look at the number of interfaces that are configured on the 8KV router, there's only 4. But if we look at the link list again, if I were to drop down here, you can see that there's other interfaces. So even though those interfaces don't exist right now, if I were to click this interface, so let's just say I want to use gig ETH7, hit create link, it's actually going to auto-populate those additional links and then assign them. So this is really good. Like if you want to add a bunch of links to a host at once and send it come over here and say I want to add additional interfaces here, you could pick the high end of the number of links that you want to use and it'll auto-populate and make that connection. Important thing to note is once you start the node, you decide you want to put additional interfaces on there, you have to wipe the node, which we'll talk about a little bit more in a minute, to actually make those changes. So anything that you want to do, you want to try to plan it out before you start the nodes. Otherwise, you have to wipe it and make the changes and then restart the configuration. So I have everything set up the way I want it. We're going to go ahead and we're going to start up the images now. So there are a couple ways to do that. I could come here, I can right click on this guy and I can just say start, and we'll let that router start. I can click on the node. I can come to simulate and I can hit start. Or from this panel, there's a nodes button. I'm not going to start up switch 2 yet, but I'm going to go to unmanaged switch. I'm going to say start right here. So if I wanted to spin up multiple nodes at once, I could select them all. You could come up here and you can unselect and select them all. Or you can just click the single one and say I'm going to start unmanaged switch. So you'll see this one will start very quick because there's not a lot there for it to do. So you can see it says it started and it's got a check mark because it's running. So what I want to do real quick before I start switch 2 is just show you a couple of the things you could do with the switch before you start it up. So if we click on switch 2 and we click on this panel, you can see that there's a couple different things specific to the node itself. There's a connectivity button that shows us the links that we have set up to each of the different switches that Nexus 9kV switch 2 talks to. Console, which is not running. On platforms that would support VNC, you could use the VNC tab to console into or GUI into the host. The real cool thing though is edit config. So here is the base config that the Nexus 9kV is going to use to start up once we hit start. I want to make a couple changes here. So I'm going to change this to N9kV-switch 2. And I'm going to come here and you see that there's a default username and password set up. Since this is all listed out in the Cisco documentation, we might not want to leave this out there, especially if we do get this set up where we could connect to it externally. So I want to change this to password 12345, and I'm going to change this to password 12345, which is not much more secure, but it does highlight that we can make the changes in the configuration before we start it. I'm going to hit save. For interfaces, I actually want to add a bunch more interfaces here. And I'm going to just click add interfaces. And you can see that I can just keep clicking add 4 interfaces and it'll keep adding additional interfaces. So I want to bring this up to 54 interfaces. And the reason I want to do that is so we're at 55. I'm going to remove this interface. So this configuration now would mimic very closely a 93180 YCFX fixed device. We have 48 ports on the front that are 11025, and then we have 6 uplink ports that are 4100. So if I wanted to simulate a configuration for a platform like that, I could set up all the interfaces I need on the virtual node and apply the same configuration I would use on a fixed chassis, a real piece of hardware, and put that configuration into CML. So I've made all the changes I want to do. I'm just going to come over here and make sure I save the config one more time. And we're going to go back to nodes. And we're just going to start this node up right here. So you can see it's queuing. We can see the CPU utilization for switch 1. It's pretty high. This one is sitting at 54%, but we can also see the host is started. So since our Cat AKV is running now, let's go ahead and click on it. Go to simulate. Click on console and then do open console. So we can see it looks a lot like any switch would look. It's started up some interfaces. It's done all the kind of boot up process. It's having problems talking to smart software license utilities. So we're just going to click here, hit enter a couple times, and we should get a prompt. And you can see here it's insert host name here. I'm going to hit enable. And now we're sitting at the exact prompt. So just like we would on a real piece of hardware, we have a virtual exec running on this Cat AKV. So we can go to configure terminal. I can do host name, and we're going to call it Cat AKV-RTR. We've got our host name set up. And because we can see here what our physical interfaces are we've used on the Cat AKV, I'm going to do int G1. I'm going to set an IP address. I'm going to do 10.1.1.1 or 254 rather. And we'll put this in a /24. I'm going to no shut the interface. I'm going to do a description of downlink to Nexus 9kV switch 2, switch 1. I'm going to type end, and I'm going to do show run int eg1. So you can see that we have our description, we have our IP address set. I can do write. It's going to save that configuration. And this is the current running config now. So you can see we've got some configuration here. You can see our interfaces are set up. If we go to edit config, there's nothing on this device yet. Like, this is how the system expected to boot up. If I do fetch from device with that configuration saved now, we're going to pull the running configuration from the VirtualBox, and it's going to be listed here now. So if we were to ever lose, like if we lost this device, we needed to reconfigure it or something, and we wanted to wipe the config to add more links, we could fetch the configuration from the device before we wipe it so that it would start back up with this desired configuration. So I'm going to come back here, go back to console. We didn't configure G7, and if we look at the configuration, we can confirm it's in its default state. Go back to console and do int G7, and I'm going to do IP address. I'm going to do 10.2.1.254. Put that one in a /24 as well. No shut. Do a description. Downlink to N9kV-switch 2. And I'm going to do a write again. And I'm going to fetch the configuration from the device. And now you can see that we've populated that additional configuration. And so again, if we were to shut this down, wipe it, make changes, and bring it back up, this is the default configuration it's going to start with. So we can see our Nexus switch is up now. We're still waiting for this Nexus 9kV switch 2 to set up. So we'll go ahead and we'll start configuring 9kV switch 1. So you can see we didn't do any configuration here, and so when we log in here, it's going to say, what do you want to log in with? So we're going to do admin, Cisco, and it logs in. It has a default configuration with no host name. I'm going to go ahead and I'm going to set the host name variable to 9kV switch 1. So now that we have the host name set up, let's go ahead and configure our interface pointing to the router, and let's get it assigned with its IP address. So we're going to do interface E1/1. I'm going to do no switch port just to make sure we're in layer 3 mode on this switch. I'm going to do IP address 10.1.1.253.255.255.255.250. I'm going to do no shutdown, and I'm going to do description uplink to cat AKV -RTR. I'm going to do end, and just to show that I have connectivity now between these two hosts, I'm going to ping 10.1.1.254. We get an unreachable, but we should get immediately 4 pings back from the host. So now I have communication between switch 1 and the router. Switch 2 is running. But before I go to switch 2, let's copy run start. And like before with the catalyst, if I do fetch from device, you can see the default configuration it had. When I do fetch, we're going to update, and it's going to show us the running config. Now you can see it changed all the username and password details to protected. It's encrypted now. We can see all the other running config information. We can see interface 1.1's configured, and none of these other interfaces are set up. Same with the management. So this looks just like a physical Nexus platform. You can see it maps out 64 interfaces, and even though we don't have all those interfaces configured here, so if I click here, you can see we've only got 3. As far as the CLI is concerned, we see all of those interfaces in the configuration. So like I mentioned earlier, if we wanted to wipe this configuration now so that we can add more interfaces, again, can't add anything. But if I wanted to do that, I could hit console, just double check that I'm good here. We're gonna go to simulate. We're gonna stop the node. Again, can't do anything here. I'm going to go back to simulate. I'm going to wipe the node. So I want to add just a couple more interfaces just because if I have more hosts I want to add down the road, I don't want to be limited by the number of interfaces. So you can see I've got the option available now. I have a couple more interfaces I want to add. So let's just go up to 15. Go back to simulate. The configuration is still here, so this is what it's going to use. I'm going to hit simulate. I'm going to hit start, and we're going to let this system boot. We're going to look at switch 2 because we did apply some configuration on there. And we're going to go to console on switch 2. So we see right away, instead of insert host name here, we've got N9KV switch 2 login. If I do admin and I try to do Cisco, it's going to come back and say, no, that doesn't work. So wait for it to error out. Type admin, password 12345. And those 2 settings that I set in the configuration when I booted it up, they applied, and now I can go here. I can do interface eth 1/1, and I'll put this in IP address 10.2.1.253.255.255.250. And because it's not in layer 3 mode, do no switch port, put the IP address in, no shut, description, uplink to cat 8kv router, end, and then we'll ping 10.2.1.254. Again, like the first switch, it's going to come back, say unreachable, and then we'll get pings back from the host. So we're able to successfully ping with the router. What other things could we see with the links? So, I told you earlier that we could click on these links, and, we can actually do some simulation or packet capture on these links. So right now, the packet capture feature is active. If I hit start, it's just going to start collecting some packets, and we'll see, what kind of communication we get. So we see that it's trying to use some DNS tools. That's probably for licensing. We wait a little bit more, again, it's trying out for tools. So we'll see what couple of packets it gets. If we click on simulate, we can see that we have 124 packets that have been sent between the 2 hosts for a total of 9,422 bytes on Nexus, and then on the Catalyst, 48 packets at a total of 4,124 bytes. If I were to come back here and say, let's stop, I'm going to come here and I'm going to click on this host. Let's do a ping. We're going to use the default VRF. We're going to target the router. Let's do a repeat of 1,000. Keep all the other defaults. And what I want to do is I'm going to start this ping and hopefully get over here and stop it. And I didn't do it fast enough, but we'll try it again. I should do a ping 10.2.1.254. Count 1,000. And we'll just leave everything alone. So we're going to try to ping. Ping is not working. The link is down as far as the system is concerned. I'm going to hit start. I'm going to get back over here real fast. And as soon as I start that link back up, interfaces come online and we see all of our packets. So we do see that we lost 3 packets because the link was down, but the other 997 packets were received successfully. The other thing we can do is we can click on this and start a packet capture. And so what we want to see is start this, click on the link, and now we can see in the packet capture we see those ICMPs that are going between the 2 hosts. So we see that we sent the ping request, we got a ping reply, and we'll see that for all 50 that it captured. So if I wanted to collect more than 50 packets, I could change this value to 100. Could change, whatever you want to set it up to. So we're just going to bump it to 100. We'll come back, start the packet capture one more time, and we'll run that. And we see now 100 packets were collected, all of which appear to be ICMP packets. So nothing else went through, nothing else was captured on this packet capture. So let's go ahead and take a look at Nexus 9K vSwitch 1 and kind of see where it's at. So you can see it's still booting up. Let's kind of look through the configuration, see what if it's done anything with the configuration that we applied. It doesn't look like it's gotten that far yet. But it's certainly getting close. It says the system's ready. So we should be getting a prompt here in just a few seconds to actually log into the box. So again, we had never set a username and password on here. We didn't change it. So it should be admin Cisco still, but we should come up as Nexus 9K vSwitch 1, and we should still have our link configured that we did earlier. And you can see it applied the bootstrap configuration, which is what's under edit config. It's verifying the image. And so just a few more seconds and we should get a login prompt. So we can see that it copied the configuration to the disk, it saved it, Bootstrap has configured successfully, and we see right away that we're booted up as Nexus 9K vSwitch 1. So even though we wiped the configuration that was on it, we're back to the state that we were in before we wiped it because we had the config backed up in edit config. So if I log in as admin, Cisco, again, password hasn't changed because I didn't make that change there. And if I do show run, we can see that the interface is configured just as it was configured in the edit config setting. So what we fetched from the device originally, what was wiped off the box when we ran wipe node and then pulled back into the system, from Bootstrap, it's all there. We're back into our operational state, and I should be able to ping 10.1.1.2.4, and it'll take a second, but again, we've got ping between the router and these two Nexus switches. So now that we have this lab running, I want to go back to the dashboard, and you can see on the screen now we have our Test Tuesday lab, and the preview is showing the topology of the lab we set up. So we know this is the unmanaged switch, these are the two Nexus switches, and this is the router. And like I had mentioned earlier, if I try to delete this lab while it's running, it's going to say certain labs can't be deleted because this one's running. So I hit OK. It says it can't remove lab because it's not wiped and it's in state started. Before I actually do shut it down and try to show what would happen if I tried to wipe it, I want to go to nodes, and I want to select all the nodes, and I want to extract the configurations. So this is going to back up the configurations from all the devices just to make sure I have the latest copy. And now I'm going to go here, select all the nodes again, and I'm going to hit stop. So all the nodes have been stopped. We're not running anymore. Go back to the dashboard. I'm going to try to delete the running lab. Again, it says it can't be deleted immediately, so even if I hit OK, it's going to say, you know what, it's stopped, but you can't wipe or you can't delete it because it's not wiped. So there's a nice protection mechanism in here to keep people from accidentally deleting labs. Not wiping them keeps you from being able to delete them. So we're going to just go ahead and start that lab back up, and we'll give it a few minutes and let it get running again. And actually, I want to do one quick thing. We're going to stop this node. I'm going to wipe. So we've got the configuration here. We're good here. But we're going to wipe this node. And I want to do one quick change. Actually, I want to do a couple quick. I'm going to create VLAN 100. And I'm going to come here. I'm going to do switch port switch port, mode, access, switch port, access, VLAN 100, no shutdown, and I'm going to save it, I'm going to start it, and we're going to let that guy boot up. So we've given a little bit of time, and the lab has come back up. Switch 2 is still working on spinning up. If we click on switch 2 and go to console, we can open it up and we can see that it's still kind of booting up. So we got a little bit longer to wait here, but let's add some additional functionality. So we can do a Ubuntu node, and we can come over here and we say add link, and we're going to connect this to our unmanaged switch, and we're going to go ahead and we're going to start it up. So we're going to simulate, start. So one of the cool things CMO has, among all the other things I've mentioned, is we have these Linux nodes in here, and I haven't done any configuration with it. You could apply a cloud config to it if you've got some default configuration you want to apply, and it'll apply this during its startup sequence. I just went with the default node configuration, and we're just going to let it boot up. So it'll take a few minutes to load up the image. We'll see that it's starting up its processes. We'll see it come up with Cloud Init here. So it's working on looking at what this configuration was to see what it wants to apply. We're going to have a default user of Cisco and a password of Cisco when it comes up. And you see we're waiting for it now to start up. While we wait for it to start up, let's add some management IP addresses to our management ports. So we'll go here, we'll log in as admin, log in as Cisco, and let's go to management 0, and let's do IP address 172.16.1.253. Actually, we'll do 1.1. Oh, and we do /24. No shut, and then this guy's still booting. This guy's still booting up. So just give that a couple of seconds. But we'll put all these hosts into the 172.16.1 subnet, and then we'll actually try to remote into them and access the terminals via SSH. So we can see now that the Cloud Init has run. It has set up some keys, and now it says, let's go ahead and log in. So we do Cisco. Try it one more time. It may not be fully running yet. It's not. So we'll just give it a few more seconds to finish loading. Generally, when it is completely up and running, you'll see some SSH key information come up, and then at that point, the users are set up on the system for you to start running. Come over and just see what the status on switch 2 is. Still booting up. And we can go back to the Ubuntu host, and we can see it looks like the SSH host key is set up, so now we should be able to log into Cisco, and now we've got our prompt. So we want to run netplan, and we want to get an IP address set up for our Ethernet host. So to figure out what I want to use for my netplan, I need to look at what my interfaces are on the Ubuntu box, and if I do IP-A or just IPA, I see ENS2 as an option, and that's going to be our physical interface that we have attached to the unmanaged switch. So if I do a sudo, and the first thing we want to do is remove etc netplan 50 cloud init. That's a default file that gets created, and we want to do a sudo vi etc netplan /01 netconfig.yaml. And in this file, I already have some stuff copied. So here we go. We have network. I'm just going to clean this up a little bit. So it's version 2. I have my interfaces. I use ENS2. and then I have the addresses I want assigned to the device. So just clean this up a little bit more. All right, so we should be good to go here. Write the configuration, do sudo netplan apply. It'll take a second, and if we do IPA again, we'll see that we have a interface configured with 172.16.1.254. Since we already set up an IP address here of 1.1 and we no shut it, I should be able to come back to this Ubuntu host now and do ping 172.16.1.1. And we see we're getting a ping. And if I were to go the other direction, 172.16.1.254, oh, we need to do VRF management on this one, however. Management. We'll see that we get a response back from the Ubuntu host. So now our 9K vSwitch 2 is running. We can log in. The one thing we did with the edit configuration where we added our VLAN and our additional interface, if we go back and do console, and do show run, we'll see that VLAN is there, and we'll see that the interface is going configured with switchboard access VLAN 100. And then we can go into our management interface, do IP address 172.16.1.2/24, no shut that, and then do a ping 172.16.1.254. We'll get a no response. Gotta do VRF management again. One of the little tricky things with Nexus switches. And we get a connection, and we should also get one to switch 1. And all of that's happening through that unmanaged switch. So now I have management connectivity to both my Nexus switches through the Ubuntu host. I can come back here and I could say, let's quit that, do SSH admin at 172.16.1.1. Are you sure? And I can go ahead and type Cisco for the password there, logged in, change this to 2, type yes, and do password 12345. So now I have management access. I can SSH to them, which if I could get Ansible installed now on this Ubuntu host, I could use this as a Ansible host to start applying Ansible configurations. So having these Ubuntu hosts or these Linux hosts within the CML environment, adds a lot of extra depth to the virtualization platform, to manage and configure your switches, and you learn how to do automation now. So if you wanted to start playing around with how you could use Ansible to configure these devices, this is a safe place to do it. What you do here will 100% apply to a physical platform. It's just going to be like the subtle differences between it being a hardware device and a software device in this case. But functionally, like, the commands are the same, the modules are the same. It's just what things you might want to do with that device in hardware that you might not do with the software side. So really cool ability to run this Ubuntu host. If you connected to this to the internet, you could pull all sorts of packages down. I'm not going to set that up here right now, but you could do a lot of additional things with this environment. So I'd say we've really kind of just scratched the surface of what CML can do. This is just some really basic configuration. We didn't show adding additional nodes. I mean, I had mentioned earlier that we've got some nodes that we've added that weren't part of the default configuration. But just out of the box, there's a lot of capability with Cisco Modeling Labs, and you can start doing some very basic modeling. Like, if you're new to networking, this is a great tool to start learning networking. When I was in college, we had Cisco Packet Tracer, which this tool is leaps and bounds beyond that, because I've got real Nexus OS images So, it's just like working with the real thing. This Cat 8KV is the same Cat 8KV that would be running out in Amazon Web Services, or that you could load in VMware and, run a virtual router on. Like, it's a great place to kind of experiment and see what it can do before you go put it in those different places. There's a DevNet sandbox for both Cisco Modeling Labs Personal Edition and the Enterprise Edition. The differences between the two, with Personal Edition, you get 4 hours of runtime. Enterprise is up to 48 hours of runtime. So it gives you a lot of time to play around with the tool, see the functionality. They've got some pre-baked labs in there that you can experiment with, or you can shut down those labs and you can run your own thing. If you do something that you really like there, you can go here. So, one of the other features is you can download your lab. So we've made all these changes. I now have this lab saved and I can open it up. I'm actually going to bring it over here. There we go. So we have this YAML file of our lab. So we can move this, around to different systems. And if I were to pull this up, if I've got all the nodes and everything available in my CML instance that I'm working with, you could 100% pull this up in that other box and it'll spin right back up and you can get back to work. So really great way to back up your work. Great way to start learning how YAML formatting's done for, very large instances of labs. There's a lot of ways to learn different things just using CML because of the way they've built the system and the way it operates. So I hope that was a good use of your time. I hope you found this valuable. I definitely want to come back, in another video and show the integrations with maybe Ansible or using CML to run like Cisco NSO or anything else that you guys think might be interesting. So if there's something you want to see, just leave a comment and let me know what you think you'd like to see run, and I'll try to do it in another video. Thanks for watching.
Successful test. I guess so.